All right, today we have scientific notation and basics of polynomials. Okay, scientific notation. Remember, this first number is between 1 and less than 10. Can include 1, but less than 10. And I have it multiplied by 10 to some power. That's what scientific notation is like. It should be written in that form. Okay, so this decimal currently is right there. I can always write 0.0. But remember, this first number has to be between 1 and 10. That means it has to go right there at 6.387. So I have 6.387 times 10 to what power? I have to get it back to where it actually goes, which is 3 places to the right. So I'm multiplying by 1,000. That's 10 to the third power. What did I say? 9. 3 places to the right. So it's 10 cubed. That's multiplying by 1,000. It moves it 3 places to the right. Okay, if I was moving it back to the left, it'd be negative. So let's do an example of that one. Let's say number 5 here. Again, that number has between 1 and 10. So it goes right there. Nowhere else will it be between 1 and 10. So it's 9.621. Let's just write it down here so I have more room. 9.621 times 10 to what? How many places do I have to move it to get it back there? I'm going to the left. So that's negative. And that's 1, 2, 3, 4, 5 places. So 10 to the negative fifth. Okay, so that is the top half. In the bottom half, when you're multiplying and dividing, I guess in division, I could go ahead and do each one individually. I could do 1.82 divided by 9.1 if I wanted to, and then do these two separately. 10 to the fifth divided by 10 to the seventh would be 10 to the negative 2. You can do that, or you can just type it right in your calculator. Now, if I type in my calculator, don't forget, I need to have parentheses around both numerator and denominator. When I'm done, that will then give me a decimal, and I have to change that decimal to scientific notation. So let's go ahead and show you an example of that. Graphing calculator online here, test nav. Come on, there we go. Oops, I move back up. Right there. It's right here in the middle top. Okay, clear it. All right. Let's move this over here like this. Let's shrink this in. Let me see so I can move this over. There we go. Looks like that's as far as I can go. Okay. So now I can see it right there. All right, parentheses. 1.82 times. There's 10 to what power? 10 to the fifth. Hit the right arrow to bring it back down. Right parentheses. Divided by parentheses. 9.1 times second log, which is 10 to the seventh. Right parentheses, bring it, right arrow to bring it down. Parentheses. Now I hit enter, and it gives it to me as a decimal. So I could go ahead and put 0.002, but now I have to change that to scientific notation, which would be 2.0. So I moved it, I put it right there because it has to be between 1 and 10. So it's got to go there for 2. Can't be the left of that. It'd be 0.2. That's not between 1 and 10. And how many places I move it back to the left? 3. So times 10 to the negative 3. Okay, so that's how you would use your calculator to do it, and you can do the same thing down here with your calculator as well. Plug in your calculator. If you use your head, 5 times 1.4 is 7, and then I'd have this times this. Negative 2 and negative 4 is negative 6. 7. Now, usually you're going to put a decimal, just so you know, they want a decimal, 7.0 times 10 to the negative 6. I think in science class, I don't know if they require that 0.0 there. But in math, we like to put that 0.0 there. Okay. By the way, speaking of that, science teachers are complaining about how poor a lot of students are at scientific notation. So now you've had it in middle school. Now you have it again right here. Okay. And so that takes care of both sides right here. 5.5 minutes. Right? Or is there another side? Oh no, we're not done. I thought we were done. That was just the first side. Back side, polynomials. Good thing I checked. I would have stopped it. Find the degree of each polynomial. The degree is the highest exponent in any one term. Now, if there's more than one variable in a term, I must add the exponents together. So an example here, that's 1. Obviously, that's 2 right there, and that can be written as, for example, a to the 0. So that's actually considered a 0-degree term. And you got 2 there and 1 there. So the degree is the highest one, so it's degree 2 of any one term. Now, here's an example of what I was talking about when I have more than one variable in a term. See, there I got 3 here, 2 there, but here 2 plus 2 is 4. So the degree is 4. Okay? So there's more than one variable in one term. Remember, terms are separated by plus and minus signs. So there's 3 terms in number 6. The degree of the first term is 3, the degree of the second term is 2, and the degree of the third term is 4, and we name the highest degree, wherever that is in the terms. All right, arrange the terms of each polynomial so that the powers of x are in ascending order. Ascending means going up, so we put lowest to greatest. Okay, let's go ahead and do 16. So lowest here is 1. Now I have to make sure I keep that negative sign with it. So I have negative 2x. Next up is plus x squared, that's degree 2. Next up is minus x cubed, degree 3. And lastly, x to the 4th, the highest degree, smallest to greatest. Okay, down here, arrange the terms so the powers of x are in descending order. That's highest to lowest. Okay, let's go ahead and do number 26. So I'm just going to put the degrees above each one. That's degree 1, that's degree 5, that's degree 2, and that's degree 4. So we're going highest to lowest. So I have p cubed x squared plus 1/3 px cubed plus px plus 5p. And there's my answer, highest to lowest. All right, now that ends at 8 minutes, basically.